Okay, Math 3, open to your table of contents. Today we'll put in notes about rational exponents. Rational is just a fancy word of saying a fraction. So I have these pre-written. Okay, rational exponents, top line and side line. So we're going to start with the fact that rational exponents, they follow all the same rules as exponents that are whole numbers. So on the page before, you guys should actually have the rules of our regular, just exponential rules. So rational exponents was just a fancy word for a fraction. Follow the same exact rules, okay? So real fast. So if you have x to a fraction of 1 over m, it is exactly the same as taking the mth root of x. So for example, if you have 9 to the 1/2, that's the same as taking the square, the denominator, the square root of 9, which is 3. Okay? What happens, though, when your numerator of your rational exponent is not 1? What if it's some other number? In that case, when your numerator is, let's say, another number, so you have n over m, your radical is still the m root, okay, and now it's x to the n. And there's another way to write it, and it always depends on the math that you do, that you're being asked. The other way you could write it is you could have the m root, so still the denominator is your root of x, but then you can actually pull that out and make it squared on the outside. And sometimes the math is easier one way than the other. So the example I'm going to show you is 125 to the power of 2/3. And I'm going to show you both ways. So the first way I'll do is this way. So I could say the third root, because that's our denominator. So our root is 3. Our third root of 125 squared. Now, using a handy dandy calculator, because I'm not doing this in my head, I would say, well, what's 125 squared? Well, that would give me the third root of 15,625. And then using my handy dandy calculator, I would then say, okay, well, what's the third root of 15,625? And my calculator would give me 25. The other way to do it is the way I like a little bit better. So the first thing we can do is the third root, because again, our denominator is 3. The third root of 125, but we can square it afterwards. So if you do that, you would do the third root of 125 first. And you can use a handy dandy calculator, or this is one of those math facts that Math 3 you should know. The third root of 125, 5 times 5 is 25, times 5. 5 times 5 times 5 is 125. So the third root would be 5. So that's 5, but then we're going to square that. Well, 5 squared is 25. So both ways give you the same answer. One way I would definitely have to use a calculator for. The other way I wouldn't. So, okay, so our next example. I have x to the 2/3 times x to the 1/4. Using our rules of exponents, when the product rule means that we can add these. Well, they're fractions. So that's going to give me 2/3 plus 1/4. Well, I can only add fractions when they are like denominators. So my common denominator I'm going to make into 12. So 2/3 would be times 4 times 4. So that's going to give me 8 over 12. 1/4 would be times 3 times 3. That's going to give me 3 over 12. So this problem has now turned to 8/12 plus 3/12, which give me 8 plus 3 is 11/12. Now, this answer is totally fine, but every once in a while I may ask you to put it in radical form. If I ask for this in radical form, your denominator is your root. So this is going to be the 12th root, that's a 12, of x to the, and you can either put the 11 here or outside. It doesn't matter. Okay. Next problem. So this one is the quotient rule. The quotient rule means we can subtract, but first I'm going to turn them into common denominators. 2 and 5, my denominator is going to be 10. So we're going to multiply this times 2 times 2, so 6/10, times 5 times 5, 5/10. And now I can do 6/10 minus 5/10, which gives me 1/10. If I'm going to change that to radical form, my denominator is my root. And then 1, technically we don't need to write it, but I'll write it. Okay? So they follow the same rules. And this one, write as a okay, so write as a fractional exponent. So the first thing I'm going to do is I'm going to take any roots that I know. The square root of 4 is 2. I don't know the square root of x, so we're going to leave that as x to write it as an exponent. There's an invisible 2 right there. So 1/2 times the cube root of 27 is 3. I'm not going to do the cube root of x to the 5th. So we're going to write that as an exponent, x to the, my denominator is 3, my numerator is 5. So now I can use 2 times 3 is 6. And I'm going to change these exponents into fractions that have the same denominator. So the same denominator is going to be 6. So 1/2 is going to be 1/2 times 3 times 3 is going to be 3/6. And I can add that, because this is a product rule, to 5/3, which is going to be 5/3 times 2 times 2. So 10/6, which is going to be 6x. 3 plus 10 is 13/6. Okay, that is our notes.